I have showed you how you can model and describe the world around you easily with UML. If you have not seen that video, you may want to watch it before this. I then showed you how you can use the model to express yourself with OCL expressions and thus access and transform the information within the model. That too is a good prep before watching this. Or you can stay on here and watch this first. What I will show in this video is how you can stack expressions together to solve all things related to use cases you want solved in your information system. We call this collection of expressions compiled to solve a specific use case a view model, because it's a view or perspective of the information within your system. So, if the classes and attributes and associations of your model is the definition of what information your system can handle, the view models are the definition on how that information is handled. Every interaction between someone or something with your system is a use case. Someone as in a human user or something as in other systems. To get a quick grasp on what view models are and how they are defined, you can always use the AutoForms feature. The AutoForm feature will create view models that match your current model. And whenever you change your model, you can just recreate all the AutoForms. AutoForms will just look on what classes, attributes and associations are available and do mechanical view models so that all the information defined in your model can be created, shown and edited by a human user. The resulting system from just running the AutoForms is fully functional but very data-driven, meaning that it is the classes that dictates the use cases rather than the actors you want to build the system for that dictates the use cases. Once you have a great implementation of the use cases, your user will not complain of needing to jump around a lot or to find relevant information. They will not copy and paste information from one screen to another, but rather they will be supported in their tasks and find all the relevant information on the screen they are on. This will, however, probably take you many iterations and a lot of real user feedback to know what information should be presented and transformed together to get happy users. Instead of trying to think really hard on this before you start, all experience point to that an agile approach is best. Do your best guess and wait for feedback, then act swiftly on that feedback and iterate like this until all feedback is mostly positive. Now that you have learned about AutoForms, you will be happy to learn that AutoForms are like manual design view models in every aspect. You can at any time adopt an AutoForm and make it your own. What this means is that drop all AutoForms will not drop the ones that you have adopted, and recreate AutoForms will not touch the ones that you have adopted. It's easy and safe to experiment with AutoForms. Remember that all changes you do manually to AutoForms will be discarded if and when you recreate AutoForms. To keep your changes, make sure to adopt the AutoForm to make it your own, or create a view model from scratch. So when we create a view model from scratch, you must first say what type it is rooted in. This is one of the classes in your model. Let's say we do one for Apple. I then decide if this requires a root object or not. Meaning, does the view show a specific object, or is it more of a view that acts on the class information, like a seeker that can look up apples but doesn't really have an apple to start with? Let's say that our view model requires an object. This means that all expressions on the root level of the view model has the self variable set to the given object, the given apple in this case. I can now add what we call columns to this view model. A column is an OCL expression. I can find the obvious ones from just right-clicking. If the expression is valid, the preview will choose a UI widget based on the resulting type information of the expression. In this case, we ended up with a byte array that contains image data, so the widget will be rendered as an image control. I can now move around the widget in the grid. I can make the available grid larger or smaller. I can make the UI widget span more or less rows or columns. But let's pause here for a while and set up an action that will bring this view model up so that we can follow along in the running application. I choose a class action. Class actions are associated to the class, in this case, the apples class. And they will be available whenever we see an apple instance in our system. This ensures that I can bring up my new view from the autoform seeker for apples. The name of the view model column is freely changeable. The name is used as a default presentation, but we can override the presentation if need be. We can also remove the label from the view if we don't need it. Let's add another expression to the view model. This expression results in a string, and then the system offers up a UI widget that is a text box. If I accidentally make widgets collide in the preview, I will get warnings that something isn't quite right with the view model. The same is true of the expression if the expression isn't valid. If the expression does not provide the result, the system cannot know what to render, and this will not work. Let's add yet another column. This one results, the expression results in a Boolean value, and we get a checkbox to render that one. If I save the model, and I can see that the checkbox is rendered there. Adding yet another one. This one ends up, the expression results in a date time. So I get a date picker. I'm gonna put that one over here. Saving, and this one refresh. Now each view model column has additional places for expressions for read-only and visible. So we can use these expressions, and they will result in something Boolean, true or false, to decide if it should be read-only or if it should be visible. So let's say that we can only see the image, and this one, we should only show that if the apple is ripe. Let's say that we have that rule. So then we can do an expression to ask, is it ripe? Self, is it ripe? That will end up in something Boolean. And it's now, that expression is set on the visible part of the image column. So if I save this, nothing changes, but if I were to say that it isn't ripe any longer, the image would be removed from view, and it will come back if I say it's ripe. And let's say that the comment should be read-only if the picked date isn't set. I can go like self picked date, and there's an operator called not null, meaning that if it's not null it will be read-only. So I guess it's the operator is null. It will result in a boolean. So if it's null, this will be true, and the comment should be read-only. No, I put that one on the wrong one. I put it on the pick date. It should be on the comment. Like that. And saving that, I can see that this is read-write. But if this were to be nulled out completely, this one gets read-only. But if I set it, I can now edit it. So we have added very simple expressions, and this is really not much difference against the data-driven UI we get with the autoforms. But we can do other things in the view model when we design it ourselves. We can do things like adding a generic column that is empty initially, and let's say that we follow the link from self to let's see if this is in a fruit bowl, and from the fruit bowl let's go to all the other fruits. So this one will return a collection of fruit, and to handle collections we really want to do something more than just having a simple widget. So we add a nesting to the view model, and we're gonna add just an empty nesting initially, and then we say that these fruits should be associated to this new empty nesting. And we knew that the result of this expression was fruits. So we will say that the type on this is fruit as well. And if we do it like this, we can actually add the details from those fruits that are in the same fruit bowl as us. So let's do that. And since this is a collection, the system will offer up to render a data grid to show this information. So if I were to save this now, I get a grid with the other fruits that are in the same fruit bowl. So this is probably us. We are the only apple, then we have 2 oranges, it looks like. But as we can do anything, we can use the power of the OCL expressions and remove ourselves from this list. Maybe we just want the fruits that aren't ourselves. So I would select all the fruits, call that variable f, the iteration variable. So if f should be different than self, and saving that. And then I'm not there. The self from this is not there, but it shows the other fruits in the bowl. And then I could change the name on this to other fruits in the same bowl. And since this can allow for multiple columns, I could like add let's see the presentation. So and another aspect when we're here and we have a grid like this, and we can sort of select multiple or one or multiple objects here, we might want to act on the selected one and or the current one that the user points at. And a view model has a built-in functionality to maintain currency variables for everything that needs it. So what we will find, if I were to add a completely new column here, let's put it over here for now, and there will be a vCurrent variable taking its name from this nesting, so I know what the user has pointed at. And those are named vCurrent underscore and new nested view model class, and I see that it's of type fruit since there are fruits in the grid. And I can take the image from the selected one or rather, let's take the comment or something like that from the selected one. So we get a comment for selected. And then we can add the comment here as well, comment, so that we see it. And when I change this, if I select this and write something, comment 1, and on the other one, comment 2. So this enables us to not be strictly data driven and just follow things that are in our vicinity, but we can do anything really. We can move around freely in the whole model to get access to all the information that's there. And if that is what is required for the use case, then we should do that. But it's really hard to guess. We need to have the concrete use case in front of us and a user that can decide if this is better or worse. And since it's very quick to do the changes, the investment is quite low in maintaining a UI on this level, and that enables you to allow for late changes. Another very often complicated thing when dealing with UI are combo boxes or switchers or selectors, and they are often used to associate a particular object to another in single associations. So it's if we were to add one of those, we could probably get help from the single link with setter. And here it says that we have these to choose from based on the model information. you can set the country of origin or which fruit bowl you are in. So let's put the country of origin in there. And what we got then was a view model column that looks like a switcher. And if we just save that, we can see that we have the different color countries here. But if we were to allow for switching which fruit bowl we were in as well. So I'm gonna add a new nested single link with setter fruit bowl. And so here's the fruit bowl, and I'll save it. And one fruit bowl is whitish, and that's the one we are in. And if I switch it to green, this should probably change. Yes, there are no fruits in the green bowl. Well, I guess we are in the bowl, but we have filtered ourselves out, so we won't show. Let's see if that was the case, why we weren't there. Gonna remove that, showing all the fruits in the fruit bowl. And now I see that we are the only one in the green one. But if we move ourselves back to the white one, we see that we have friends in the bowl. There is one more complexity to the view model, and that is that we need to have the ability to create information and do advanced things to change information. More advanced than just showing up a widget for a specific attribute. And that's possibly done with a action button, and we can add a column and an action column. It's really not anything different than the other columns. It's just that it has this checkbox checked is action. So once we have it as an action, the OCL editor has changed a bit. It now says action editor. So what's the difference between the action language and OCL? Well, action language is unique for MDriven and Mocotype, and it has the ability to not only speak model or talk model, it can also do. It can change information. What do I mean by that? Well, we can, for example, create a new fruit bowl. With a create operator. And if we hold that in a variable, call it bowl, and use the new one and set its material or the color, because that was the one we show, and we set that to red. And this is also an operator that's unique to the action language that isn't available in OCL, because OCL can't really change information. It can only follow information that already exists. But this is the assign operator, and that will assign a value to a specific property. So if I were to do this, and let's call this action button add bowl, and saving that, I have the add bowl action in the UI. I can see here there are only one green and one whitish, and then there's some empty bowls over here. But if I add a bowl, the red one is available to us as well. Let's see, out of screen. So if I were to put us in the red one, and I can push this button many times and I will get many red ones, and I can do cancel to revert all these changes. Now I don't have them. Another type of important operator is the add operators on multilinks. So from the bowl that we have, we can follow the links to fruits and do add, and that expects a fruit, because that's what's going in here. But fruit is abstract, probably we couldn't just have fruit. We're gonna choose one of the subclasses. Let's choose apple. So I'm gonna do apple and the create operator. So that would add a new fruit bowl called red, and that fruit bowl would also get an extra apple in it. And I'm gonna save that. I'm gonna add a red bowl and switch my owner to that red bowl, and then I have, this is me, and this is another apple that was created just now then, but that hasn't been assigned an image yet. So you have now seen the basics on how a ViewModel is used, and how you can access your whole model. Even if it's super large, you can navigate to and from objects to show or hide or make visible anything you see fit. There are many ways to add columns to the ViewModel, and I have shown you the most straightforward one. We also have this UI first that will help you to mimic what is done with the autoforms. So you could just go on this one and say that I want a, what we call a document autoform, the auto-generated template that autoform uses, but now we instruct it to fill it in our view model named ViewModel 3, and that would replace everything and just pour everything very data driven. If that was a mistake, I simply press Ctrl Z to revert my changes. Another important aspect of ViewModels is the ability to seek. And to set up a seeker, you can also do the UI first and copy seeker autoform, and then you will get these new search expressions. And this is, if we were to look at this, it says that it's going to search Apple all instances, and it's going to search the comment if it's like some variable that we have set, and show those in the list. So that's one way to get access to objects to work on, and that's commonly used to know where to start for a user. Search something and then they find particular instances, and then they work on those instances and continue like that. Another way to add columns to the ViewModel is to use these widgets down here. If you want an editable text, you know that you want one of these. You can select this tool and draw one out. I want it here, all right. Then you get one with a null value. But you can ask the system to say what are the easy expressions from here. Well, the comment would be one expression. Okay, I'm gonna use that expression. Now it has filled in here. Or if you want to do something very different, that's fine as well. And you can use the suggested name, which is comment in this case. So that would become invalid because we already had a view model column named comment. And then we could simply change this to comment 2. And if we have 2 comments like this and save, they will of course show the same thing and propagate the same data. So now we see it in 3 places because we have that one as current. You have now seen the declarative view model. With the ability to model anything, express yourself fully with expression, and then use the results of such expressions in view models, you now have all that is needed for describing any information system. If you don't feel like this was impossible to understand, you have what it takes to define the gist of any information system. This gist can act as the perfect runnable specification, or the prototype, or even the machine-read blueprint of a multi-user enterprise-grade information system. Normally, use cases screens in information systems are expensive to wire up and even more expensive to maintain during the life cycle of the system. But with Mocotype and MDriven, you have seen that it is easy to set up and easy to change and easy to maintain.